We now discuss the solution of a problem from the section Quadratic Equations. The question is on the roots of a given two quadratic equations. This question has appeared in the joint entrance examination main held on 25th June 2022 in the second shift. The given question is, let A, B belongs to R, the set of real numbers such that the equation ax square minus 2bx plus 15 is equal to 0 has a repeated root alpha. If alpha and beta are the roots of the equation x square minus 2bx plus 21 is equal to 0, then alpha square plus beta square is equal to, we are given four options. Option A 37, option B 58, option C 68, option D 92. So we have a quadratic equation ax square minus 2bx plus 15 is equal to 0, and it is given alpha is a repeated root of this equation. Further, it is given alpha and beta are the roots of this second quadratic equation x square minus 2bx plus 21. Then required to find the value of alpha square plus beta square from the given four options. We now discuss the solution of the problem in detail. We are given alpha is a repeated root of this quadratic equation ax square minus 2bx plus 15 is equal to 0. Let's call this as the equation 1. Now, the roots of 1 are given by minus of minus 2b, that is 2b plus or minus under the square root of minus 2b whole square, that is 4b square, minus 4 into a into 15 by 2a. Because a is sitting in the denominator, a is not equal to 0. Now, what are the conditions a root to be repeated? We have alpha is a repeated root of 1, that is a root is to be repeated, then its discriminant must be equal to 0. What is its discriminant? The discriminant is under the square root in the roots of the equation. So that is 4b square minus 60a. So d is equal to 4b square minus 60a is equal to 0. That is discriminant is 0. Then the repeated root we will get as 2b by 2a. Therefore alpha is equal to 2b by 2a. So alpha is a repeated root of this equation. Then the discriminant 4b square minus 60a is equal to 0 and alpha is equal to 2b by 2a. So that is b square, 4b square minus 60a is equal to 0 means 4b square is equal to 60a. Therefore b square is equal to 15a and alpha will be b by a cancelling 2. Right. So these are the two conditions we got. Now let's continue. We are also given alpha and beta are the roots of this second equation. The second equation is x square minus 2bx plus 21 is equal to 0. Call this as the equation 2. Agreed. Alpha and beta are the roots. Therefore, we write alpha plus beta, that is the sum of the roots is equal to minus the coefficient of x, that is minus the coefficient of x, that is minus of minus 2b by the leading coefficient, that is the coefficient of x square, that is it is plus 2b. Alpha plus 2b is equal, beta is equal to 2b, and the product of the roots alpha beta is equal to the constant term divided by the coefficient of x square, that is 1, that is 21 only. So we have alpha plus beta is equal to 2b and alpha beta is equal to 21, and we want to find alpha square plus beta square. Therefore alpha square plus beta square is equal to alpha plus beta whole square minus 2 alpha. It is well known for us. Alpha plus beta is 2 beta, 2b. So the 2b whole square, that is 4b square, minus 2 into alpha beta is 21. 2 into 21 is 42. That is 4b square minus 42. And we know what is b square. B square is equal to 15a. Therefore, 4b square is equal to 60a. So, in the place of 4b square, we write 60a minus 42. So, the story is that if you find a, that is sufficient. Then substitute here, you will get the answer for alpha square plus beta square. We do it in the next slide. So far we have alpha square plus beta square is equal to 60a minus 42. Let's call this as equation 3. Agreed. And we are given alpha is not only the equation of 1, it is also the equation of 2. And also we know alpha is equal to b by a. So alpha satisfies the equation 2 also. So wherever there is x, you write alpha, and wherever there is x, you write b by a. So since alpha is equal to b by a is a root of the equation 2, so b by a whole square minus 2b into b by a plus 21 is equal to 0. Take the LCM and clear the LCM. That means this will imply b square minus 2b into b, 2b square into a, because the LCM is a square, plus 21a square. This is what you get it. Now, b square is equal to 15a. So, for b square, 15a you substitute. For 2b square, that is 30a into a, that is 30a square, plus 21a square. So, this will be minus 30a square plus 21a square is minus 9a square. So, 15a minus 9a square is equal to 0. 3a is common. So, if you take out 3a common, 5 minus 3a is equal to 0. A is not 0. Therefore, 5 minus 3a must be equal to 0. Therefore, 3a is equal to 5. Therefore, a is equal to 5 by 3. So, a is not equal to 0. That is why one value you will get. So, now alpha square plus beta square is 60a minus 42. The a value we got it now 5 by 3. So, substitute in this. So, there from 3, equation 3, alpha square plus beta square is equal to 60a minus 42. That is equal to 60 into a is 5 by 3 minus 42. 60 into 5 by 3 is 100. 100 minus 42 is 58. So, that is your answer. The answer, that is alpha square plus beta square value is 58. That is what you have to find. Let us look at our options. And our answer 58 appears against option B. Therefore, the answer to this question is option B. That is the detailed discussion of the solution of the problem on the roots of quadratic equations. And I am sure that you have understood the solution of this problem. I wish you all the best. Thank you.